Hello.
It says we are live.
If it says so.
Okay, so if it says, it must be live, right? Okay, so hello everyone. I'm João from Portugal, and I'm joined today with my colleague and good friend Stefan Adolf from Berlin. And we already have the opportunity to meet our speakers for today on the green room. That it's the name from backstage on the Crowdcast. And they are all from different places. So we have really apart time zones. Let's see how it works. And we were talking that maybe our kids will come here because, you know, COVID situation, everybody's working from home and with their families. So if you see some kids running around here or with the speakers, don't mind them. They are just passing by and enjoying the talks. So today it's the fourth Coding Earth Global Meetup. It's the fourth time that we are doing it online. And we were talking that we don't really enjoy it as much online as the live, in local events, because we are like several communities like Coding Portugal, Coding Berlin, Coding Leipzig, and this is the way that we found that we could keep the events going. It's doing it online. So we are trying to do it. We are looking forward to getting local again. What are our mission? Well, our mission is,
I mean, the good thing about doing it online, we don't have to pay for the pizza. So I hope everybody who's currently watching has got some beverage or something good to eat with her. Yeah, I try to open my beer in a second.
Yeah. Okay, so after the event, we can all get together and drink a beer online again. So our mission is we want to be a friendly and open hub for developers. Everybody is welcome. We only have one rule. It must be code-centric, so all the talks have to be about code. Everyone is invited to talk, to suggest, or to code. And regarding the speakers, we are always asking for speakers. So if you want to give a talk, just let us know and we get the stage for you. So, and Stefan, you are talking the cast platform. How can we interact with the platform?
I must admit, I only every second viewers. If you, I should switch next slide. I did it. And just to for everyone who's here who maybe never have joined the Crowdcast before. So as you might have noticed, Crowdcast not your Zoom experience or something. It's more like webinars, and we decided to use that because it's simple just to moderate the speakers, so to join or to invite them to the stage, and it's quite interactive. So I mean, you have a chat and you have an ask a question button down there. So if you have any question, you can just ask it there. Everybody sees it, can vote it up or down. And what's really awesome, and if you want, we can definitely try that today. We can also invite you, like all the attendees, to our screen and ask your question live. So if you have some question and you have a decent webcam and some audio on your computer, you're absolutely invited to also take the stage next to the speaker and ask a question just live. Yeah, just tell us in the chat that you want to do so. Tell us in the little ask a question box down there, and we will happily drag you onto the screen. This is why we chose Crowdcast. So since this is a meetup, the Crowdcast is sometimes missing a little bit of these like socializing features. You just use the chat box, and we also are maybe considering using Zoom for one of the next meetups. If you have any opinion on that, like if you want to tell us, people, why are you using that Crowdcast beast? It's not working for me. Just tell us, and we'll happily switch to something else. If you notice that, and if you feel annoyed by Crowdcast or whatever, maybe you're not into all the chat thing, you can also join us on YouTube. If you go to coding.earth, you will find the link. I'm not posting it here. Everything that you see is streamed with a maybe 3 seconds latency also on YouTube. And you can also ask questions there. I will try to take care of it and answer it there. There's a reason why we're doing that on YouTube. It's recorded. And if you have already checked out that Coding Earth website recently, we are putting online all the recordings so you can revisit them days later if you're missing out the good thing. I mean, all this virus thing taught us one thing: we don't have to do things synchronously anymore. Besides now the speakers, Dan, Gil, Joao, and me, because we have to edit somehow. you're the lucky people. You can watch us anytime if you like what you're seeing. And already got an opinion on that. Check out later. Yeah, there's also Joao we can wait on for upcoming time. There's definitely the idea that Coding Earth is more like, okay, we're opening a crowdcast or a Zoom channel and have like people doing monologues like I'm currently doing. If you want to join us doing more things like attending hackathons together, attending conferences together, I don't know, asking questions, giving answers, learning something together, we're absolutely open to get you into the whole thing. We got a Slack channel there. Not everybody likes Slack, I know that, but it works quite well for us. And just join us on Slack. You should find the join link on the website. Otherwise, I'll share it shortly also in the chat. You can get in touch with us anytime, anyone. And as George has said, there might be a time where this will happen in person as well again, which is currently happening in Portugal. So we have been doing meetup sessions in Lisbon. We did them in Porto. We once did them in Coimbra. And of course, we're doing them in the sunny Algarve and Faro, where Joao is very close currently, I guess. And in Germany, we're currently in Berlin, Stuttgart, and Leipzig. And if you want to open or you want to drive your own Coding Earth, whatever it is, meetup location later on, so if that virus thing is over, you're happily invited to get your own. If you want to drive it, you see this is not like rocket science. Everybody could do it, even me. You're happily invited to start off your own local Coding Earth meetup session. Joe, are you excited?
Sure, let's do it. I'm looking forward for the speakers because they are bringing something cool for today's session.
Shall we have a look at whom we brought together this time? We only got 2 talks today, but what for talks? I guess they're really going to be amazing. The first one is by Gil Fink. He's from Israel currently, and he's giving a talk about JavaScript memory leaks. I have a memory leak in an Express service right now, so I'm excited for Gil's talk. Exactly, I think this is what Gil is going to teach us now in every second. And I think he's going to talk for around 30 minutes or something. This is more or less his time slot. You're absolutely open to ask any question in the Ask Question box. And as said, after the talk, we're happily inviting you to the stage. And after Gil, there will be Dan Forbes from San Diego, California. It's very early there. I mean, what's very early? It's now 8, I think 9 or 8 in the morning. And yeah, he's going to talk for, I think, 2 or 3 hours, if you can make it, on custom blockchains on Substrate. I know that there are some people already joined who are in the whole blockchain thing. This is going to be, I think, the simplest way to understand how to do it. And trust me, it's not the simplest thing to do on Earth. This is really like a little bit complex stuff. And I'm pretty positive that Dan will teach us all how to do it in the most simple way. So this is going to be very amazing. With that, I'd like to invite Gil to the stage. If Joao wants to say something, this is the right time.
I'm looking forward to the speakers, so let's go. No more small talk.
No more small talk. Get into the point of it, right?
Well, I tried to tell a joke the other day because we have some time to spare, and you didn't let me. So now let's go to the talks. I don't want to say anything.
So,
hey, Gil.
I'll share my screen. Hello, Gil. There you are. How can I hear? Okay. On Crowdcast, it's sometimes awesomely hard to find the right buttons. Gil, good to have you here. It's already 10 past the hour. What time is it in Israel?
It's 6:10 in Israel. It's 1 hour before you.
Okay. All right. Time is in Portugal.
So in Portugal, it's 4:10.
Cool.
Okay. We got all this clock comparison every time. Gil, I hope you are very well prepared. Tell us something about yourself in the beginning.
I will tell you something about myself during the talk. And just one thing, as mentioned, I'm from Israel. Currently, it's 35 degrees outside of my house. We have a heat wave, and I'm Very anxious to start to talk about memory leaks.
Hey, Fernando, what is frozen? You mean the video?
What?
It's working very well for us. No, was somebody in the chat saying it's frozen.
Okay.
Ah, but you hear my voice. You can see me waving. I can see myself waving on YouTube, so I assume this is on your side, Fernando. I'm sorry.
Okay, you can see my screen, I hope.
Right, we are totally unimportant. Gil is really important and his video. I'll make it full screen now, and you take the stage for the next 30 minutes. Thank you, Gil, for being with us.
Thank you, and let's start. Hello, everybody, and welcome to Coding Earth. And in the beginning, I want to start with a story. The story happened 2 weeks before COVID quarantine started in Israel. My customer appointed me and asked me if I can come to them because I'm a consultant. And they said that they have a very major memory leak. So when I hear about memory leaks, I'm very urgent to jump on the wagon and to get that challenge, because memory leaks are a challenging thing. So I got to their office and after 3 hours of investigation, I found the problem. And sometimes it can take longer than 3 hours. What was the problem? They had a major memory leak because they had some very big data source, and they were cloning that data source and passing all those clones to different objects. And each and every object had a reference to those clones. And each and every clone of data included something like 18 megabytes of data, which is ouch. And you know, cloning sometimes is a bad thing. And after something like 35 minutes, we finished crafting the solution to the problem. We created the one source of truth in their application, a service that gave the objects that needed the data, that data, and only that object was storing the data and not all the different objects. So that concluded their problem, the company problem. But this brings me to really memory leaks. Memory leaks will happen to you during your work, even if you are not a JavaScript developer like me, even in places like C++, C#, and etc., etc. So what we are going to do in this talk, we will talk about memory usage and how we work with memory, and then we'll drill down into how we can detect memory leaks both in front-end code in JavaScript and in back-end code in Node.js. So a little bit about myself. As I mentioned, I'm from Israel. I'm Sparksys CEO and I'm a senior consultant. Sparksys is my own company. It includes only one employee, myself. I'm freelance. I'm both a Google GDE, Google Developer Expert in Web Technologies, and a Microsoft MVP in Development Technologies. This might mention that I have a split identity or something like that, you know, Microsoft, Google. I wrote a book in the past, I think around 2014. It was published, called Pro Single Page Application Development. It included the ways to create single page application. It was written back then with Backbone.js and ASP.NET. Sorry, both of those technologies, not both of them. Backbone is, you know, less used today. Angular, React, Vue, whatever. And ASP.NET Web API was replaced by .NET Core, ASP.NET Core. So what we're going to do in the next 20 minutes. I'll start by introducing how we work with application memory. Then we'll talk a little bit about memory leaks in JavaScript. And then we will try to understand how the process of detecting memory leaks works, both in front-end and in the back-end. So let's start with memory lifetime. When you want to use memory in your application, you will allocate that memory. Not you, but the operation system will allocate that memory to your program, to your application. Once the memory was allocated, you can use it. How do you use it? The program is going to read from the memory and write to the memory. And that's simple. Once the memory is unused, you will release it, or the operation system will release that memory to the free pool of free memory. So you can look at the memory like a connected graph. What I mean by that, you have a root. In this slide, it's the node 1, and that graph starts from that node, and then there are connections, references from one memory to another. So what about the 0 here, the node 0, an unreferenced memory? What's going to happen? So this is where garbage collectors comes into place. A garbage collector is a software that looks for unreachable objects and then remove them from memory. By that, it is clearing the memory, and then the operation system can use that memory later on for allocation, read, write, whatever. And there are two main algorithms for garbage collecting. One called reference counting garbage collection, and the second is mark and sweep. So what is a reference counting garbage collection? An object is said to be a garbage if there are 0 references pointing to it. So if you look at this example, A has 0 references, so it is cleared. Because it is cleared, B is cleared, and then the counter for references in D is subtracted by 1. The problem in reference counting garbage collection is, circular references, how you can use those, or how you can detect when something isn't references if you have circular reference. This is what, sorry, this is why mark and sweep is more used today. What is mark and sweep? This is the algorithm that V8, the engine, the JavaScript engine uses, the JavaScript engine of Chrome uses underneath. A mark and sweep, the garbage collector will mark the garbage collection route, and then it will travel from that route to each and every node that is referenced and mark it as active. All the other non-referenced objects will be swept from memory. As easy as that. What is a memory leak then? A memory leak is something that might happen to you. It's when the application doesn't require some memory, but that memory isn't returned to the pool of free memory. And that can't happen in JavaScript. It will happen in JavaScript. So these are common JavaScript memory leak pitfalls. Let's start. First, accidental global variables. This is when you're not using let, var, const, or whatever to declare some variable. It is easily be detected by linters, and it is easily can be avoided using the string use strict in your JavaScript code. So don't fall into that. In the past, that was something that was causing memory leaks from time to time. Forgotten timers and callbacks. You are starting some interval by using setInterval function. That setInterval gives you a handle that later on you can clear that interval. But if you're forgetting this timer, then the callback for that timer will continue working and working and working. Another thing here is callbacks for functions. You have an onClick function and some object that gets that callback, and you're not clearing that object. And as when that happens, you are not going to clear the callback, and etc. etc. So you can use clear interval or clear timeout, or unreference the callbacks that you are using if you can. The third pitfall is closures. when you have a reference from the parent, sorry, when you have a reference for a closure is a variable in some function that is staying alive even though the function finished its execution. So when you have closures, unfortunately, they will stay in memory after the function ended. Those variables will keep being alive in memory, and they will get stuck in memory up until you clear them. So closures can cause memory leaks. Out of DOM references, this is only in the front end. When you're removing some or detaching some document object model object from your HTML, for example, but you have some reference to a callback, for example, on click event or things like that, this can cause DOM references to still be in memory and then cause out of DOM references memory leaks. So now we understand the pitfalls that can cause memory leaks. Let's understand how we can profile, or how do you do profiling for memory leaks. So first of all, establish baseline. By what I'm saying by that, you can open the browser in incognito mode, which won't affect with extension your environment. You can create a Git branch or anything else in order to establish that baseline. Once you establish the baseline, you did draw the line, you start by collecting the data. Later on, we will see how we can collect the data. You will collect the data, and then you will analyze the results. According to the analysis that you are going to do, you will tune up the application. After you tune up the application, you will test and measure again to understand if the memory leak was you really detected that memory leak and you find some solution to that. And you will keep on this cycling of profiling up until you will solve the memory leak. If you didn't solve the memory leak, then you will collect the data again, analyze the results, tune up, test and measure, and etc., etc. So this is the process. So how can we detect a memory leak in the front end? First of all, the browser developer tools. I'm using Chrome developer tools, but you can also use Firebug or the developer tools in Edge, in IE, to do the same things. You can also use the object called performance on the window object in the front end. That object gives you the opportunity to get data about the memory usage of the application. You will have to craft something by yourself in order to do that, but this is another place that you can use in order to detect memory leaks. So with that, let's start and let's get into our first demo of today. So what I'm going to do right now, I'm going to run some HTML. Let's run it. Okay, so we have an application, and once I'm going to press this button, this application is going to leak like a ship that is drowning. Okay, and pressing this stop leaking will stop the leakage. So I will open first of all the developer tools, and I will show you one place that you can start with when you're trying to understand if you have a memory leak. So you can open the performance monitor, okay? Right now, the performance monitor will give you a lot of indication about the DOM nodes, the JS heap, which is 3.9 megabytes, and the CPU usage. Let's press the button and let's see how the leak is starting. Okay, you can see that the JS heap is starting to grow and grow and grow. We have a lot of DOM nodes entering our application. Let's stop it for a second. And you can see that all these lines, all this graph is getting higher. So we have a lot of DOM nodes here and a lot of memory. And this memory isn't getting back to the pool of free memory. You can see that these lines, the JS heap size, isn't going down. Okay, so we have a problem. This is one way to understand or to see a memory leak in action. So you will use the performance monitor and run it. Another place that you can use is the performance tab. let's start by recording. I'm getting into the Performance tab in the Developer Tools, and I'm starting a profiling. I press the leak button. 1, 2, 3. Stop that leakage, and let's stop the profiling. Now what we are going to see here is a lot of details. So don't be afraid of this timeline. It can be frightening. What you should look at when you're searching for memory leaks after you profile something is this blue line here. You can see here that this blue line is the heap, and the heap is going higher and higher, getting higher and higher. Okay, so we started, you can see in this indication, from 11 megabytes, and we finished around 14 megabytes. Another place that you can see is this place. Okay, this is the memory of the application during time. So you can see here the green line is the amount of nodes that I have in the browser, HTML nodes, and you can see the blue line is following that same thing here. Okay, so we can see that the JS heap is also getting higher. So this is another place that you can use in order to detect or to monitor your application. Let's see the third place. Memory. Memory tab can also help you to understand if you have memory leaks. So what you're going to do is take a snapshot, and after you take one snapshot, which is the baseline for your application, and it takes some time, let's wait for it to finish, I will press the leak button, and then a few seconds later I will stop it. Okay, so here is the snapshot. Let's press the leak button, and let's stop it, and let's take another snapshot. So now I have two snapshots. One is the memory usage at first. This is my baseline. And the second is what happened after a few seconds, a few minutes, or whatever. Okay? Now I will wait that this snapshot will finish. And what you can see here is that I have a few options. For example, comparison. I can compare the the second snapshot to the first snapshot and see how things are going to look like. Okay, you can see that there are a lot of deleted objects. There are a lot of new objects here. The delta is 600. The allocated size is very big. We have a very big array here, okay, that you can see here. And this is the place that you can monitor the objects and see if you have memory leaks. How do you monitor the objects? You will open those scribblies, and you will try to understand what is this object later on in your application. So if you're asking yourself, what is going on in my application? Why it's so leaking? So let's take a look at the code of leak and stop leaking. So the first code here is, I'm just adding event listener to the make leak and stop leak buttons. In the stop leak, I'm clearing some interval, and I'm writing to the console something. The make leak is the thing that creates the memory leak. What I'm doing here is I'm setting some interval, and in each and every 500 milliseconds, I'm just pushing to X here a new array with length of 100,000. I'm also running some function called create nodes. Create nodes will add 100 nodes, HTML nodes, divs, into my application, into my into some place in my document, and this will cause the memory leak because each and every 500 milliseconds, I'm adding a new array that has some memory footprint. And I'm also adding a few nodes, 100 nodes, to my DOM. And these things will eventually crash my application later on because I will reach out of memory exception because this interval will, finish all my memory in about 5 to 10 or even 15 minutes. So this is the example of how we can detect memory leak in the front end. And so let's talk about the back end. how can we detect memory leaks in Node.js? Dan asked about Express, so Dan, this is for you. So you can also use Chrome developer tools to monitor Node.js application. How do you do that? You will run Node in inspect mode. Once you're running in inspect mode, you can use the memory tab in order to locate memory leaks. Another way to do or to monitor your application is use some code. For example, Node memwatch or headdump are very known libraries that helps you to register to events and dump some memory usage into the disk. And later on, once you have those dumps, you can look at them, open them, and search for the memory leaks or understand if you have a memory leak. So with that, let's detect a memory leak in a backend. So I'm jumping back into my IDE. And in this IDE, I'm going to do node --inspect index.js. This is going to run my Node application and in inspect mode. This is the flag for inspect mode. Once I run this, I can open the browser. Let's open the browser, Chrome, inspect device. You will go to Chrome --inspect -devices, and you will wait that it will find this this application. Okay, so it found the application that I'm currently running in Node, and it enables me to inspect that application. Once I'm pressing the inspect link here, I can see the memory usage right now, and I can take a snapshot. Okay, so this is going to be my baseline. Application is running. I have 2.3 megabytes. And now what I'm going to do is I'm going to create a memory leak. How can I do that? I'm going to use autocannon. This is a process that will run and for 30 seconds and blast the localhost 3003, which is the current location of my server, with HTTP requests. You can also use a tool called Siege to do the same thing here. So let's run it. And what's going to happen right now, I'm going to blast the server with a lot of requests. And now I can take a snapshot again, and you can see that the memory got to 5.9 megabytes. And let's take another snapshot, and you can see that it's 8.1. And again, I'm going to use the comparison from the third snapshot to the second or to the first, and you can see here that a few things jump into our vision. The amount of new objects, date objects, and object here, and numbers is getting higher and higher. This is probably the cause to our memory leak. So what's going on in my application? Let's take a look at the application. Let's understand what is going on. So in my application, which is very simple, I have a server that for each request is going to push to this array an object with the request URL and date. So logs aren't supposed to be in memory. You should dump them into file. This is the solution to this memory leak, okay? But it shows you that when you have big objects and big arrays, you can create a memory leak later on in your application. So don't stick big objects into your memory, both in Node and in your front end. So that was the example of how we can detect memory leaks in the backend. I'm not going to drill down into how to use headdump, for example, or the coding options, but you can take a look at those libraries later on after you saw this session. So JavaScript memory can, and it will leak eventually. You saw a lot of pitfalls that we should be aware of in this talk. please monitor your production before, so you will find memory leaks as soon as possible. The customer that I talked the story from the beginning was in a critical application that was used by fire departments. You don't want a fire department application to crash during some accident or something. So be aware of that. Be prepared to solve the leakage problems as soon as possible. Thank you.
Thank you, Gil.
Thank you.
Besides the firefighters, I was just thinking about that Dragon capsule from SpaceX that also was running cloud application, right? So if you have a memory leak in space, I think you have a big problem.
That was a very. They had a memory leak. It stopped the engine.
Did they have some? I mean, I just can remember the first man on the moon. They really got a memory leak, right? So in that Apollo lander, the lunar lander, there was this little message popping up. Nobody knew what it actually meant in 1969, and it was actually memory. It was not really a leak. It was like out of memory error.
Yeah.
So close, not landing on the moon that day. Nice. Gil, we got one question by Dan, of course. He says, I think of the phrase memory leak in terms of non-garbage collected languages. What's a memory leak in a garbage collected language?
There can be a memory leak in garbage collected applications. We had such thing. It's not really a memory leak in the passion or the way that you think about. I had the opportunity around 2007 when I was in a bank. We had the application and we had a memory leak. What caused the memory leak was in application in SP.NET in C#, which is an application that you have monitoring for. It's a garbage collected application. And it should handle all your memory for you, and etc. C#. And what happened was that we have very big arrays that holded a lot of data in memory, and the servers had something like I think 4 GB memory, and that memory was used up until 3.9, and then the servers were crashing. So we learned how to use distributed cache later on, and that was our solution. So this is not, something that you think about as memory leak, but it is a memory leak. When you are using big objects in memory, you are storing those objects inside your memory. They are stuck in your memory and they are not moving. And then the application won't be able to use more memory later on, or your server won't be able to use more memory because you are wasting a lot of memory. So in environments like C#, Java, you can have memory leaks.
Dan, I hope that was answering your question.
Me too.
I just figured out that there are more buttons. I'm just clicking all the buttons, like done answering. The good thing is, if you click them, you get these little time pointers somewhere in your video recording, so you notice when the questions are answered. So the second one was from Seftap. I will just click this button. Let's see what's happening. Wait a second. She doesn't seem to respond.
Okay.
Seftap, if you're not responding, I cannot invite you to the screen, and then I have to read the question. Never mind, I'll do it. Here we go. Have I understood that right? Start answering. If a node has an event handler, and if we delete the node, we create a memory leak?
Again, what was the question?
It's in the question box, actually. If she understood that
okay,
right,
sorry.
If a node has an event handler and we delete the node,
has an event handler.
So is the event handler not garbage collected in the sense?
So no. if the node has some reference from a variable in your application, then both the node and the event handler will stay in memory. Okay, this is the DOM out of DOM reference problem. Okay, so for example, if you have a variable in your front end, you're doing document get element by ID. You're finding some element, and it has an event handler. Then later on, that variable that you're using is still in memory, and you are removing the element from the DOM. Okay, and once you remove that element from the DOM, it still has a reference in your application from the variable that you did get element by ID with, if you didn't clear it. What that means for us is it stays in memory up until you will clear that variable. Okay, so this is the idea of out of DOM references. I hope that this is related to the question. The problem with event handlers, that you should remove event handler once you're doing add event listener, okay, in your application. You should do remove event handler if you're not going to use that event handler anymore. This is something that can cause problems later. For example, I'm using a front-end application with Angular, and in some sort of a way, I had to use add event listener in my component. Later on, I moved from the first page that I was currently in it to the second page, but I never removed that event handler. That means that the handler itself is going to stay in memory even if you moved from one page to another, because it's a single page application. It stays in memory, and once you will return to that page, it stays in memory and it is never referenced again. So
there's also a good example in the React world. For example, if you use React with hooks and use that effect hook, you're actually supposed to return a function that is cleaning up the stuff that.
So in React, as you said, Stefan, thank you. When you have a use effect hook in your applications, then it returns to you the cleanup function, or you should return a cleanup function if you want to clean after yourself. In Angular, it's ng destroy, if I'm not mistaken. In React, it's in use effect. In use effects, it's just returning. The use effect will return cleanup function. You should return that cleanup function. I don't know how to do that in Vue, but I guess that there is a way to do that in Vue as well.
I guess there's maybe one or another Vue developer around here. So if you got the answer, you can also put it in the chat. Let's continue with Fernando. Fernando, I'm also just inviting you to the screen. If you have a camera, you can follow that.
It always takes some time for the configuration.
I know, but I know, I see, he's accepting. This means he's coming.
Yeah.
All right.
All right.
I think this is the first time that you have a guest, right?
Can you hear me? I don't
have
the camera.
Yes.
My computer. But I just want to check if it's possible to provide some unit tests to validate the using of the memory if we have memory leaks in the execution. Like in C, we can use the valgrind to check if we have some memory leaks. I don't know if we have something similar in JavaScript.
So you can add checks for memory leaks in unit tests. It will be difficult, but it's something that you can do. Okay, or add checks in your continuous integration. There are tools to monitor memory leaks, which I didn't mention because they cost money. But there are tools out there that can help you to to monitor application, JavaScript application or Node. And you can add unit testing because, again, if you're going to use the window.performance object, you can get the memory footprint and you can check it later on. So it's not detecting memory leak, but rather checking if the memory usage is going to be higher or bigger, or etc. Okay, I hope that I know have an answer, and not. I hope that it's answering your question.
Yeah. Thanks. I just want to know if it's possible to, like you said, if I have some continuous integration, and before to accept the code for production, I can validate in a little bit if it's.
There are tools. Not I don't remember the name of the tool that I used. It was something like 5 or 6 months ago. And like cache, my memory is leaking. But there are tools that can help you to monitor that even in production. Okay.
Oh,
So,
okay.
so
Thanks.
I will get back to you with the name of the tool if you want after the session.
Okay, I appreciate it. Thank you very much. Congratulations.
Thank you.
Thank you, Fernando. Okay, so with that, Gil, I think Team Coding Earth would like to thank you very much for giving this awesome talk.
Thank you for hosting me.
It was a pleasure on our side because it's actually quite simple for us to do it. We happily give this option to you. See you next time. If you want, you can stick around, Gil. Join the chat, find the tool that you just mentioned, put it just there. You're happily invited to tell our people everything you want. Thank you so much for being here.
I will stay for a couple of minutes. I will see if there are more questions in the chat, and then I will head back to my kids.
All right.
So it was nice being here. Thank you for hosting me.
Thank you, Jill. Bye.
Ciao. Are you impressed?
Yes, very. And now that I see, I might have some memory leaks in my apps. I have to check it, but there are some things that I wasn't thinking of.
Yeah.
And what about today's event? I think this part of inviting people to the stage or to the screen makes it some more humane, right? It's different from the normal talk and code part.
Yeah, it's always good. I mean, if everybody's invited to our stage, as long as they're still, hello, Dan.
Hey.
Hey, guys.
I must admit, it was also a long day for me. I just invited Gil again. So, Gil, I'm sorry. I don't know if you had a second talk. I rejected you again. I know. Thank you. Okay, Dan, good to have you here. This is San Diego.
Yep. So 8:45 a.m. here, but for me, I've already been well into my day by now. I'm a morning person. Parity is headquartered actually in Berlin, so I'm accustomed to working with people on Central European time. This is old hat for me.
As a Berliner, and especially from Köln, I must say, I already visited that office. It's right across the street actually from my place where I'm living. If anybody's interested in seeing a nice office with, I think they can get a better coffee machine, but the rest is just splendid. Right? They have this crazy good event space, and everybody's ready to go there. Okay, Dan, I think you are going to bring us the most understandable introduction into Substrate development ever. I think.
No pressure, right?
All
right.
I forgot
to start off.
I forgot to mention one thing in the beginning. There is currently a hackathon going on. It's called the Hack You Summer, and we are more or less proud partners of them. So at least we're trying to communicate a little bit. I think I'm not exactly sure because I'm not following that hackathon. There might be still some slots left, and I think there's still some time to submit hackathon or hack ideas. So if you are inspired by what Dan is presenting you now, you want to jump into Substrate development, I guess this will be very usable for taking part in Hack Your Summer, right?
Absolutely. Yeah, this is going to be a great starting point to help people get ready for Hakusama.
And I think there's also money to win. Okay, I'm not really well prepared, but let's assume there is money to
There
win.
is. There is. You're right. Yeah.
No, buy something nice. So if you watch this talk and you take something away and you try it out and you want to hack on it, you can even take some money home with you. I think it's running until mid of August or beginning of August, so you maybe still have one week left. With that, I would like to give it away for Dan now and have fun. I think, how long is the talk taking? 1 hour, 2 hours, 3?
Ideally, it's going to be 30 minutes. I really doubt that's going to happen. I'll try to keep it to 45. I hope it doesn't go as long as an hour. I'm going to try to keep it from that.
If you want to shut him down, just write it in the chat, right? You can like boxing handshake.
I'm used to being pulled off the stage with like one of those canes. You know, that's usually how they have to do it to me. So you won't hurt my feelings. But yeah, I'll kick things off by sharing this link to the GitHub repository that you may have just seen me looking at. And we're going to return to this. I have some code that obviously I'm sharing with people and that we'll walk through a little bit. But before we jump into that, I do want to go through some slides just to kind of help you understand the things that we're talking about. So before I kind of really get into the slides, I'll just do a very quick introduction. My name is Dan Forbes. I'm a developer advocate for Parity Technologies. As I already said, Parity Technologies is headquartered in Berlin, and we're a blockchain infrastructure technology. So if you're, kind of familiar with the blockchain / Ethereum space, you may be familiar with Parity. We kind of gained recognition for developing Ethereum client written in the Rust programming language. And that sort of, spun off this amazing company that I now get the opportunity to be a part of. And so one of the big projects that we're working on right now is what's called the Polkadot network. It's kind of similar to the Kusama network, which is the platform for the Kusama hackathon that we were just learning about. But the Polkadot network is kind of like its grown-up professional cousin. And so the idea is that the Polkadot network is kind of this blockchain of blockchains. So there's a concept where a parachain can hook into a parent chain, or technically what's called the relay chain. And in this case, Polkadot would be this kind of composing blockchains in a way that enables you to pass messages without trusting one another and all kinds of wonderful things. But sort of the takeaway here for the purposes of this presentation is that Parity is very involved in blockchain infrastructure. We have a long history of using Rust to write some of the best blockchain infrastructure in the world. We're currently developing this kind of blockchain of blockchains. And so in order to do that, not only do we need to develop a blockchain, but we need to make it easy for other people to develop blockchains. And so we have released this framework, Substrate, which is a Rust framework for writing blockchains the easy way. And as was mentioned, that's kind of like saying this is the easy way to build a nuclear submarine. There's a lot that goes into a blockchain, and that's why I really felt the need to kind of have some slides before I dove into the code so that we could kind of meet our minds when it comes to terminology. Yeah, so with that in mind, I guess let me just state that like the goal of this presentation is that regardless of what your current understanding of blockchains is, I hope that if you're someone with some experience with coding, you will leave this presentation with a better understanding of what a blockchain is. And then of course, a much better understanding of how you can use Substrate to help you build a blockchain, and maybe even why you would want to do so. So let's get into it. So I'm assuming that most people are relatively familiar with the idea of blockchains, but let me just kind of touch on some of the basics here. From my point of view, the real value add that a blockchain brings is this idea of decentralized consensus. It allows a trustless group of individuals, a network, a trustless network, to come to consensus on the state of some system. And so another way to kind of envision this or think of this is the idea of a permissionless database. So most database services that we know of, they're like, a central server that one entity manages, and then maybe other people have permission to hook into that database and kind of, establish consensus around the state of that database because they all have access to this material that's being managed by a central server. But the idea of a blockchain is that it allows for permissionless, decentralized consensus. So just like in any peer-to-peer network, everyone in the network has equal ownership in the state of the system. And there's this idea of trustlessness through cryptography that allows us to come to decentralized consensus on the state of that system. So what I am not here to do is tell you all about cryptography and how our consensus mechanisms work. I am not a cryptographer. I'm a software engineer, so I'm a consumer of these algorithms, not a producer of them. But for the purposes of this, workshop, just keep in mind that what we're talking about here is decentralized consensus enabled through cryptography. And so now when you think about what can we do if we are able to come to decentralized consensus on the state of a system? That's actually a very, very powerful thing. If you're familiar with the ideas of distributed computing or, anything, censorship resistance, governance, you see these ideas that I have represented here. As software engineers, we live and breathe on this idea of abstractions, and the notion of a fault-tolerant, decentralized consensus system is an incredibly powerful abstraction that is a net new one. And I strongly believe that at Parity, we are bringing that to life in the best way possible. So let's talk about how we're doing that. So when you think about Substrate, what I want you to always keep in mind is this idea of modularity, composability, and flexibility. I am a software engineer, but I'm part of the marketing team at Parity. So I'm not part of the core development team. And when I look at what these guys are doing as a software engineer and, understanding that good code is always the result of, making things modular and composable, they have just done that in all the right ways. And knowing that Rust isn't always the easiest language to work with, it's just really, really well written code that creates some abstractions and some idioms that make it really easy for you to kind of express these kind of complicated concepts and compose them in a way that's scalable and that makes sense to you. And so because even Substrate as a framework is so big and complicated, there's kind of this meta framework within a framework that we call Frame. And that stands, I can't even remember, it's like the framework for runtime aggregation of modular entities or something like that. So basically what the idea is Frame sets up this abstraction of a runtime, a blockchain environment as a composition of code modules, which is a very common and powerful abstraction to software developers and not one that is necessarily common in the blockchain world. And so kind of what I want you to understand from this slide is that a lot of work and a lot of good work has gone into making Substrate and Frame highly usable. So there is a learning curve with it, but it's really fun code to play around with. So I hope that you are inspired by this presentation to kind of get over that learning curve and kind of play around with it with me. Of course, Parity does not work in isolation. In particular, we work very closely with the Web3 Foundation, which is a not-for-profit foundation with the goal of promoting technologies for decentralization and creating cryptographic research. And so we rely very heavily on the research that they provide. Let's talk a little bit about the design principles that underlie Substrate. I mentioned that it defines some useful primitives and implements them, and I think that's a really important thing to keep in mind. It just kind of sets up these concepts of what a blockchain is. And I've provided a little diagram here, but let's talk about it. First, there's this idea of the runtime, and that's a really important one. For the purposes of this conversation, I think you can effectively think of it as the blockchain. It is the core logic that defines how blocks within the blockchain are executed, how that state is determined, all of these kinds of things. So, you know, Substrate kind of has a clear definition and abstraction around what a runtime is. Then, of course, there's all of these other ideas, like what exactly do we mean by a blockchain block? When you talk about a blockchain network, there's the runtime, of course, that we just talked about, but then there's all the different nodes in that network, the clients that make up, that are running that runtime. And so Substrate has an abstraction for what that means, and it helps you build that. When you get a little deeper, there's this idea of forkless runtime upgrades, which is a very, very powerful blockchain abstraction. It means that you can change the logic of your runtime without really needing to change the outer client. Let's look at this diagram just for a second and kind of break it down. So here we have the Substrate client. This is the binary that's running the application that allows us to participate in the peer-to-peer network. And so this client does a number of things. There's this peer-to-peer networking here that allows us to communicate with the other nodes in the network. And then what that does is it kind of, there's this modular consensus mechanism that we use to come to consensus on the state of the runtime. And what is really this kind of interesting, important factor about Substrate and the abstractions that it creates is that the runtime is actually part of the storage that the client maintains. And so that's why you can do these quote unquote forkless upgrades, because you don't need to change the client, you just need to change the code of the runtime that it's maintaining in its storage. Most Substrate blockchains have an abstraction, I should say an optimization, which is that there's a native runtime. You see that this runtime that's in storage is compiled down to WASM so that it can run kind of anywhere. WASM is this interoperability layer, but there's also a native runtime that lives right in the client. And this is just an optimization. If the native runtime and the WASM runtime are the same, we prefer the native runtime, and that offers a performance advantage. If they differ, then we end up reading the WASM runtime for storage, which is not quite as performant, but it offers this highly powerful abstraction of forkless runtime upgrades. And then, of course, there's an RPC server that allows us to interact with all of these capabilities. So this is kind of really Substrate here, the Substrate world. And then Frame is this framework that helps you define the runtime in particular. It really helps you write this part, the core execution logic of your block time. And the way that it does that is by exposing a macro language, which is basically like a programming language inside of a programming language. And again, defining some really important primitives that help us interact with that we define through this macro language. So what is in a frame? That's kind of my what's in a name reference there. I don't have the cool GIFs that Gil has. He beats me soundly on that front, but I have my fun little play on words. So there you go. So what's in a frame? Storage is really, really key to any kind of blockchain. That's what it is. It's consensus around storage. So of course, Frame is going to have storage abstractions. Transactions are the ways that you basically interface with that storage. You manipulate, create, read, update, delete kind of stuff. Errors and events are the ways that the blockchain runtime communicates to users what's going on within the blockchain. We'll talk a lot more about all of these things, but in particular, we'll talk about this idea of a trait configuration interface, which is used to help configure a frame. I guess I didn't mention this, a frame palette, which is, it's kind of this particular jargon that we use to define a frame module. We call it a frame palette. So you use this configuration interface that we call trait to kind of configure the palette. And then of course you can define public interfaces and functions on that. And so this is kind of a little diagram just to illustrate that when you're using Frame, the idea of the runtime kind of becomes this composition of all these individual modules that create the total set of capabilities that your runtime exposes. So, you know, time stamping blocks and saying this block occurred at this point in time, that's a powerful capability that a blockchain might expose. Assets, or, you know, like a token or something. So you can kind of build all of these capabilities into your blockchain with Frame. So that kind of gets us over the terminology hump. I'm going to check really quick. No questions, just want to make sure. Okay, good. Okay, so let's go check out the workshop project. If anyone has any questions, now is a good time to kind of ask them, and I can pause and answer them. But otherwise, you'll see that what I did is on the slides here, there's this link, and it actually takes you to a specific commit in the workshop project. There's kind of 3 commits of this workshop project. So the one on just the master, like at the tip of the coding.earth branch, it has like the solution and everything. So if you come down here to the workshop, it says like, don't use this one, start the workshop from this commit. And that's where the link in the slides is going to take you to. And this just basically has like some dependencies included. We can actually just look at, I'll show you what I did in this commit. It's not super interesting, just some documentation stuff, and just added a few dependencies. So you don't have to worry about that when you're doing the workshop. Oops, okay. So now we'll go back here. And so in between the slides and the workshop, this is basically just kind of going through a lot of the stuff that I talked about in kind of greater detail. So please review this on your own. You'll see that I've dropped in lots of links to, you know, these rather complex topics that I've been talking about, so you can learn more about them. Cool. So before we dive into the workshop, I'm gonna check. Okay, we have a question, I see. Can you put all capabilities listed on the slide into the same frame, or do you have to select a limited number within one frame? Great question. Guys, if you want to click, then I'm going to answer, I'll answer this question right now. So Anais asked a great question. Can you put all capabilities listed on the slide into the same frame, or do you have to select a limited number within one frame? Excellent question. So remember that frame is the name of the framework. And I didn't do a very good job of explaining that from the outset, so my apologies. And then the modules that live in that framework are called palettes. So just a quick little tweak on this question would be like, can you build it all into the same palette and then use Frame to compose it all into the same runtime? The answer is that you could, but that goes against the idea of Frame and why you would want to use Frame. The whole idea of Frame is that you split code up into, you know, kind of discrete minimal modules of minimal concern. And so creating some big massive mono palette is not super in with the design patterns that Frame is trying to encourage. And another thing that I didn't do a very good job of mentioning was that today I'm certainly going to show you how to build your own frame palette or modify an existing frame palette. But the other thing is that Parity maintains an existing library of battle-tested palettes, all these things here in the main Substrate repository under this Frame branch. These are all of our core Frame palettes that we maintain. And so we've already exposed a lot of these capabilities in kind of modular palettes for you. And so a lot of the times you may not even need to write your own palette at all. It's entirely possible that you may be able to create a blockchain. Awesome. I'm glad that this is helpful and nice, by composing existing palettes. But if you find that there's maybe one little gap that exists in all of these existing palettes that we provide for you, that's when you write your own palette to kind of narrow in on your specific domain logic. And so what this means is you've decided that you want to write a blockchain because there's some novel use case where a permissionless database is going to be important to you. And so rather than having to worry about cryptography and consensus and all of these things, all that you need to worry about is that little tiny piece of domain logic that you want to encapsulate, and you write that in a frame palette, stick it into the node template, which is what we're using as our workshop today, and I'll talk about that a little bit more in a second, and you're good to go. And that's what I'm going to show you in this workshop today. So excellent question. I'm done answering that question now, guys. I know I talk a lot, so I'll always try to help with that. Okay, cool. So would love any more questions like that, but let's get back to the workshop. So let me quickly, so as I said, the runtime in this project, and let me just tell you a little bit about what this project is. As you can see, I am working in kind of this, like, it's a branch of a fork of the official Substrate Developer Hub node template repository. And so this is basically a minimal, fully functioning frame-based Substrate node ready for hacking, as you see. So this is basically everything you need, ready to go, minimal blockchain, ready to run, awesome cryptography, RPC server, everything handled for you. And so what I'm going to show you now is how you take this relatively straightforward node template and make the changes that you need to encapsulate some custom domain logic. So let's look at this. So I showed you the many frame palettes that ship with the core Substrate repository. We looked at that. These are all the frame palettes. And then what I'm going to show you is that we're going to modify a template palette that comes with the node template, and it's in the palettes directory. So this is what it looks like before the workshop. This is all part of the template palette, and you can see that there's some pretty helpful comments in here to kind of give you a sense of what's going on. This is really a learning tool, so we try to make it useful for that. And so let's look at the trait, because I think this is one that I haven't done a very good job of explaining what it is yet. I think, when we talk about like storage and events and errors, that's all kind of evocative to developers, but the trait may not be super evocative to developers. So let's talk about that. Basically, I like the way, I like to call it the configuration trait. That's very helpful. And so if you read this comment here, it says configure the palette by specifying the parameters and types on which it depends. So we talked about this idea of Substrate being a very flexible framework where things are very modular and composable. So you have this blockchain runtime, and it kind of has this idea of an event. It knows that blockchain users need events to interact with the blockchain, but it doesn't want to be super specific about what an event is. Substrate is very modular, very composable. That means we're built on interfaces, not implementations. If you spent some time studying computer science, that may be a familiar concept to you. And so what this trait in Rust is just another word for interface. It's a powerful interface system that's used by the Rust programming language. So this is almost calling this the interface. And so what this says is, if we want to include this palette in a frame runtime, we can include it in any frame runtime we want, but we need to come to some kind of a meeting of the minds on what an event is. And so that doesn't mean that we need to know exactly what the implementation of an event is, but we do want to know the interfaces that it exposes. And so because this palette is going to emit events, that's kind of like a dependency that it has. It needs to emit an event. It needs to have an awareness of kind of how the parent runtime interprets the idea of an event. What are the interfaces that it relies on in order to interact with an event? And so because this palette needs to emit events, we have to configure it to do that. There may be other things that we want to configure, like one of the things that we're going to do in this workshop is we are we're creating a registry for nicknames, basically. Users are free to associate a nickname with any account they control. Now, in any application that you develop, you have to be mindful of storage. And this is particularly important when it comes to blockchains. As I mentioned, blockchains are basically all about storage. And so one thing that's very common when you're writing a palette is to want to provide some configurable bounds around how large that storage can grow. And so one thing that I may potentially want to pass in here to my configuration parameter, this trait, is how many nicknames will this palette allow? So going back to the idea of what frame is, it's this idea of creating a runtime through composable modules. So this idea of associating an account with a nickname, that's a pretty reusable idea. And furthermore, it's a rather abstract idea. I can kind of just off the top of my head, like think about ways that different people could use that abstraction. So I don't want to be very severe when it comes to configuring that capability. So rather than creating this palette with some kind of a specific bound on the number of nicknames that may exist at any time, because of course these nicknames, they're just going to be materialized as storage in my blockchain. It'll be, you know, like we'll see, but it's a mapping from an account to the nickname. So we have to store this information. Rather than having right here within this palette some kind of a bound on the total number of nicknames that may exist, what I would say is like, okay, this palette knows that there needs to be a bound on the number of nicknames that may exist, but I don't want to be super specific on how big that bound is. So let me show you an example of what it might look like when we use the trait configuration parameter to configure something like this. So this is a slightly more complicated palette. Don't worry about it too much, but let's look at this part right here. You can see that I'm in my trait configuration trait, and I have this idea of an asset limit. You know, this should be very evocative. We're managing some list of assets. These materialize as storage items in my runtime storage. And so I want to allow people who may be including this palette in their frame runtime, I want to give them the ability to limit the number of assets. But I don't want to say really how they do that. Basically, all I say is you need to provide me some type that's going to return an unsigned 128-bit integer. And as long as you give me some 128-bit unsigned integer that I can interpret as the asset limit, I'm cool with that. You don't have to give me a 128-bit unsigned integer. You could give me a function that calculates a 128-bit unsigned integer based on some dynamic factors or something like that. So that this trait configuration interface is kind of a squishy one, but I hope that helps you understand it a little more. You use it to configure the palette as well as using it to come to consensus with the outer runtime on the interfaces you're relying on. So then we have storage that we're defining. Again, this is all part of the template palette. I'm not going to go over this too much. We'll talk about it in the workshop. Already going over time, I apologize. And then, you know, we declare events. Events are emitted when a runtime event, when a runtime function executes successfully, and then an error is returned when they don't execute successfully. And then we're able to define some functions, we call them dispatchable functions, because it's invoked by a user and then dispatched by the runtime on behalf of that user. And so this is what allows you to hook in to these capabilities that you provide. And if you'll notice, these are all defined in these decal with a bang at the end code blocks. These are Rust macros. So what's actually happening in here is this is almost like a programming language within a programming language. And so if this syntax looks a little funny to you, that's because it's basically what's called a DSL, a domain-specific language. And so you can learn a little bit more about the syntax for declaring these storage items by following this link, but we'll talk about it a little bit more. Let's see. Okay, cool. All right. So with that in mind, let's update this this template thing that I just showed you to add some new capabilities. So I'm going to go to this node template repo, and obviously I have a bunch of stuff going on, but I'm going to check out this branch that, you know, I was telling you, just the one where I added the dependencies. So you can see this is just what we were looking at earlier. And let's see, this is not the repository I'm looking for. Here we go. Okay, so now we're in this the repository that's part of this workshop project. And let's go check out in palettes, template, src. We'll go to lib. So now this should all look very familiar to you. This is what we were just looking at. So this is what we're going to be updating. And so now let's.
Again, I think it's better if you scale it up just by one step. In your.
Thank you. On Visual Studio Code.
Right.
And probably also here. Yeah, thank you for that. I appreciate that. Always a helpful hint. Okay, so let's do that. Apologies for that, guys. Thank you for the interruption. I appreciate it.
If you look at your TV, usually it's good, but if you have the video encoding in between, and sometimes, you know.
Oh, yeah.
This is.
Oh, no, totally appreciate it. Let's view.
I think it's Control Plus. That's the Linux machine. Oh, there you go.
There we go. Okay, okay. So we are going to be updating this, and now I hope everyone can see everything. Okay, cool. So let's just go and take a look at what we're going to do. So we're going to create a decentralized registry, and this is me using my fancy cryptographic terminology of unique pseudonymous identifiers. And really, a pseudonym is just a nickname. So that's me not being so fancy anymore. So there's a kind of an interesting caveat around this decentralized registry of unique identifiers. Users can register any nickname they want as long as no one else has already registered it. And so you can see this is like something that's really, really easy to control with a centralized authority. But if you're trying to control this with decentralized consensus, this is very, very difficult. How do you determine who controls which nickname in a decentralized, trustless way? And if you want to learn more about this, Google Byzantine fault tolerance, and you will not be bored in quarantine ever again. There's plenty to learn about there. So that's what we're going to do. We're going to create a way for people to create a decentralized registry of unique nicknames. I'm doing this all locally. Unfortunately, Rust is a very, very powerful language, which means the build times can be rather long. So I have pre-built this workshop, which I know is not the most satisfying developer experience. So apologies for that, but it's one of the things that I had to do to try to kind of fit everything in here. I promise you this all compiles. I did it over and over and over again. Okay, so let's see. How are we going to implement this unique registry of nicknames? So as I kind of mentioned, one thing that we need to do, very simple, we need to associate, well, okay, sorry, taking back a step. First thing we want to ensure that these nicknames are unique. So how do we ensure that these nicknames are unique? Pretty straightforward from a computer science point of view. We just create a map of nicknames to Booleans of whether or not they're true or false. And as you can see here, what I'm highlighting as the nickname is just this array of bytes, a U8 vector, an array of bytes. And so that could really be anything you want. It could obviously be a string, or maybe you use some other encoding to represent nicknames. But as long as you can do it as an array of bytes, you're solid. So this is the storage structure that we're going to use to see if a nickname has already been claimed or not. We're going to check in this and we're going to look up the nickname that someone wants to register. And if it maps to true, we know that it's already been claimed. If it maps to false, all's good. We can register that nickname for the person who wants to register it. So let's include this storage item in our runtime because we're going to need this capability now. So we'll go ahead and add this here, and you can see that's very simple. Again, refer to the documentation for a more thorough examination of the syntax. But the name of the storage item is names because that's what we're tracking, the nicknames. Don't worry about this right now. This is syntactic sugar, helper function. The type of names is a map, like we talked about. Don't worry too much about this right now. The idea here is that because storage and hash maps in particular are so important to Substrate, you can actually specify the hashing mechanism that the hash map uses under the covers. And so that's what I'm doing here. We provide guidance around that, but it's kind of out of the scope of this workshop. So really, really, really what you need to take away from here is I am declaring a storage item. The name of this storage item is names. The type is a map, and it's mapping a byte array to a bool. And what that represents is whether or not a nickname has been claimed. Hope that's solid for y'all. Cool, no questions. Okay, so let's go back and do, now we're gonna do the next one. So now we, theoretically have determined whether or not a nickname can be registered. How do we now register that nickname? As I kind of mentioned, basically what we do is we declare another map, and this one is going to map an account ID to the nickname that it has chosen to claim. So hopefully that should be pretty straightforward based on the discussion that we just had. So I'm just going to drop that right in there. So now I've kind of set up my two storage structures. I think this is a very productive way to think about runtime development with Frame and Substrate, is always think about like, how are my capabilities, because that's what you're building, is user-facing capabilities. How are they really just abstractions on top of storage? Because that's basically what they're doing. So now we have our storage abstractions laid out, minimal storage abstractions. And if you can think of a way to do this more minimally, get rid of one of these storage structures, oh, I'd love to see a PR. That would be amazing. Let's do it. Beat me at my own game. Okay, so now, of course, in our ideal world, someone is going to claim a nickname, and we're just going to want to let people know about that. This is part of how our blockchain operates. We broadcast to anyone who wants to participate in this network that a change has happened. Very, very common kind of pattern in blockchain development. So I'm not going to talk too much about it, but just keep in mind that these functions, these dispatchable functions, if they're successful, they don't return anything, they emit an event. So that's what we're declaring here, is this event. We're using this helpful macro, and you can see we got some nice documentation there. This helpful macro to declare an event that we're going to use to indicate when a nickname has been successfully claimed. And then, of course, we have to cover the opposite case where a nickname is not, we can't claim the nickname for the person that they want to claim, probably because it's already been claimed. That's the only error case that I've coded into this workshop. So now we just kind of, we add our little spot for that. And you can see that these are just enums. They're really simple. It's like a flag kind of that indicates that something has happened. And in Rust, enums can have data associated with them. So I don't believe it's common for errors to have metadata associated with them. It's just idiomatic based on the name, but events may have metadata associated with them. So you can see here, I'm saying that a name was claimed, and I'm specifying the name and whom it was claimed by. That will be part of the event that's emitted when that's successful. All right, so now we have everything that we need to write our dispatchable function. And that was a little pop-up from my teammate there, who is fighting that express memory leak that I was just talking about. So we will be watching that later. That was a really helpful presentation there. I appreciate that. So now let's kind of look over this this dispatchable function that I've written and that I'm going to include in the runtime. You can see I've tried my best to do a pretty good job of providing some documentation. This is important in a deep code base like a Substrate blockchain. So I'm specifying, what are the conditions on which this is going to return an error? What event is it going to emit on success? This is out of scope of this workshop, but just know that this is basically saying that this has to have a valid signature associated with it. This function, we expect it to be invoked by someone outside the blockchain like we've been talking about. And in order to do that, they must make use of all these cryptographic goodies that help us ensure decentralized consensus. And then, of course, we go into a pretty thorough description of the complexity, specifically with respect to really storage of this this function. And so you can see that it's going to do 1 storage read, 2 storage writes, and we provide some documentation around that. And so this is, again, out of the scope of this presentation. This is kind of a cryptographic economic mechanism that helps prevent spam, but we associate a fee basically with invoking this function because it is going to incur computational costs. And so that has to be associated with some fee on the user. So this is basically boilerplate code for most Substrate dispatchables. We're just going to, as I was mentioning, ensure that it was signed and actually get the identity of the person who is invoking this call. It's kind of, you can almost think of it as this sort of syntactic sugar that our macros provide for us. These dispatchable functions automatically have this first parameter, which is the origin, the person invoking the call, and you can see it doesn't have a type associated with it. So this is where we kind of get into this language within a language idea. So we pull that out, do a little magic with that using macros and helpful frame stuff. And now what we're going to do is we're going to read that storage item that we created for ourselves, and we're going to see, does our array of names, does this vector of bytes that this person wants to register as their nickname, does it map to a true value in our runtime? And if it does, that means it's been claimed. It's not a unique nickname. We cannot allow this person to register it per the rules of our runtime. And per the contract that we've set up with our users, we're going to emit a name not available function in that, error in that case. And so again, this is just kind of like a helpful macro that wraps all of that logic, but this should be very, very evocative to you. Ensure that names does not contain the nickname that we want to register. And if it does, emit a name not available error. In particular, return a name not available error. So now we've kind of checked our preconditions. And so now we're sure that whatever this person wants to do, it satisfies the rules of our runtime. So we're going to allow them to register this nickname. What does that mean? We update the value of the names map. So now we indicate that that name has been claimed. And then we associate the person who invoked this dispatchable with the name that they want to register. Storage has been updated. We emit the event. And then this is essentially like a void return. As I mentioned, we don't return success. We kind of return errors and emit an event that indicates success. So just checking to see if there's any questions about that. I don't see anything. So, I'll check back in 1 second. Feel free to ask them if you have them. And so where am I going to put this? I'm going to put it right underneath these existing dispatchable functions that are already there, kind of part of the node template that you can use to help you write these things. And so, as you can see, I do have this hooked up to an IDE, although I don't think no, this isn't going to be working right now. So again, please trust me that this compiles, and actually don't trust me, but pull it down on your own machine and build it yourself. That would be my dream. But just so you can kind of get some enjoyment out of this, let me show you what this looks like when it's actually running. I am now going through these commands. I'm skipping the build command, and I'm coming down to these commands. It's going to help me to launch this pre-built binary that I already created. Okay, so this is the one that I created, the binary that I created. And so in particular, just so you guys know, it is, I built, no, not this one. It's the tip of this, the tip of the branch there. So if you just check out the tip of the branch, you'll have all the solution and everything. But before I get started, I'm just going to make sure that I don't have any weird like state lying around, you know, basically clean my environment. And now let's go ahead and launch this custom blockchain that I created. Only took us, what, like half an hour to get here? But hopefully it was exciting and interesting. So this is what it looks like when you launch a Substrate node. I love that our core devs use emojis. I'm like the biggest fan of emojis. And so it really makes it kind of fun to like look at this output and kind of see what's going on. And so because we're running this in a local development mode, I don't need any other peers in the network to create consensus. They're testing consensus mechanisms that allow us to do this on our own. We also have tutorials that show you how to create a multi-node network. I'll show you that when we're done. But for now, this is just a single node network for testing purposes. And you can see that this single node network is both creating new blocks and also finalizing blocks. So those are kind of two complementary consensus ideas, and I encourage you to learn more about them. They're out of the scope of this presentation, but know that the node is providing these two consensus-related capabilities: creating blocks and finalizing blocks. Very interesting, exciting stuff if you're a nerd like me. Oh, we got a question. What's the actual compiler result of a frame-based node? A distributor that's fully libp2p? Oh, great. This is one of the, the others are supposed to run to build. Yeah, so you can go ahead and I'll start answering this question. This is a wonderful question. So yes, and I believe that I actually did answer this, which isn't to say that it's a bad question. I answered it already because it's such a good question. And so when you build the workshop, what you're building is a node, a client. You are building this thing. Keep in mind, please, that what I am talking about is a specific part of Substrate. It's a frame-based Substrate node, which you really need to identify as like a framework within a framework. And if I pull back a level and don't use frame, there are many other ways that these kinds of things can materialize. But we're really, because Substrate is so modular, so composable, so flexible, it makes it very hard to provide concrete, solid answers to any question. So really allow me to remain pretty focused on the frame-based node template that we're working with today. This is going to cover 80+% of the use cases that are out there in the real world right now. But going back to that idea that Substrate is a framework for building nuclear submarines, the node template is like a really awesome, not nuclear submarine. It has everything you need, but you could take Substrate and build some really crazy stuff that I haven't personally even begun to scratch the surface of. So again, sticking in my spirit of taking a very long time to answer a very simple question, when you build this project, what you get is a Substrate node. And please, as I did, you can interact with that node. You can execute commands like purging the chain. You can run the node in development mode. There are other modes in which this node can be run, and you should explore them by running this help command and kind of checking out all the different capabilities and configuration parameters that this amazing tool, toy, whatever you want to call it, the node template, which I kind of live and breathe by, all the different capabilities that it exposes. Awesome question. Thank you so much for asking that. Okay, so now I got my node running. And so now we actually want to like make use of these capabilities. How exciting. And so I didn't mention this, but we are going to use kind of a semi-official ecosystem tool called the Polkadot.js apps UI. So I have the link here for you. And so this is the link to the main page, polkadotjs.org/apps. And then in particular, we're going to go to the extrinsics app within this kind of, app of apps. And that's going to allow us to invoke the dispatchable functions that we talked about. Extrinsics is kind of another jargony term for this idea of a dispatchable. It's a little bit more nuanced than that. But for now, an extrinsic is a dispatchable, is a transaction, if you're familiar with blockchains. And then I'm providing this query parameter that's going to say, okay, Polkadot.js apps UI, I want you to connect to my node that I'm running on my local machine that I just spun up. So let's go check this out. And while that's happening, I'll just, okay, cool, no more questions. Okay, so here we are. This is Polkadot.js apps UI. Because I have already kind of gone over, let me just get through the workshop and then we can maybe do a tour and go over some questions. So when we launch the dev chain, we have some accounts that are pre-funded with tokens. And I actually I go through all of this in this documentation that I provided for you. In particular, look at the chain specification file to learn about how we define and pre-fund these accounts and everything. But for the purposes of this workshop, just know that there are accounts that are defined and pre-funded, and the Polkadot.js apps UI gives us a very nice way to interact with them. We don't have to type the account number, we just select it from a drop-down. So now I know that I'm going to use this account that we're calling Alice to invoke this dispatchable function. And I want to invoke this function on this template module. I know, again, I'm interacting with the frame-based runtime. I know that a frame-based runtime is comprised of palettes. So if I want to invoke a function on one of those palettes, I need to name the palette that I want to invoke the function on. And so then if we go back and we look at the name of our dispatchable, we named it register name. So let's see if we can find that. There it is. You see there's some magic that went on with, the naming and everything, but, no big deal. And so now what I can do is, as Alice, I can provide any hexadecimal value that's a valid byte array. And you can see that means that it needs to contain an even number of nibbles, or else it's not a byte array. So I'll add one more. 1983 was a beautiful year, if you ask me. Look at that. Success. Extrinsic success. Register name. Alice just registered 1983 as her nickname. And maybe we decode that as a string. Maybe Alice just really likes this idea of 1983. I mean, it was a good year, as I said. And so I guess I did say that I wasn't going to show you around too much, but let's look. So we can see here that the Polkadot.js apps UI, it tells us that this event was emitted. And it's really cool. It actually tells us this event happened in the 74th block. And it happened in the first extrinsic call in that block. So now let's go click on block number 74. And I can see I don't know. Okay, I can't. Oh, I clicked on this block 75. It's a dynamic UI, so it moves fast. Here we go. So you can see it tells you all this information about how the nickname was registered. So this is this whole idea of like decentralized consensus. It's here, it's in the registry for everyone to see, part of the blockchain, and Polkadot.js Apps UI is like an awesome way to, like out of the box, interact with all of these things. Okay, so let's go back now, and I'm gonna follow the steps of the workshop. And so I'm gonna try, go back, so let's just, I'll tell you what I'm doing here. Same, different account. So now we're using the Bob account, same palette, same dispatchable, and the same nickname. So what do we think is going to happen? Bob is not going to be a happy guy. No, not a happy guy. And you can see expected, extrinsic failed, name not available. So Bob has to pick another nickname. 2001 was a pretty good year, I guess. I had a lot of fun in 2001. Maybe I'm dating myself. There we go, success. And so now what we can do, I mean, this is cool that you can like register these nicknames, but of course you may actually want to query them and, you know, build other layers on top of them. So now Polkadot.js Apps UI provides mechanisms for querying chain state. So I can see that Alice is using 1983 as her nickname. If I go and I see like Dave, we didn't register a nickname for Dave. There you go, we see that. Bob seems legit. And then furthermore, if we go and look at this array of just like mapping names to whether or not they exist, yeah, that's expected. Also expected. Did anyone register 1976? They did not. So, you know, these things always seem kind of simple when like you do them. 1978. Oh man. Okay. Let's do it. Let's do it. But yeah, I hope you see like, let's give poor Dave a nickname, man. He didn't get a nickname. He feels bad for himself. Oh, because Dave he doesn't have funds. So there you go. That's us using our economic incentive mechanisms. If we look here, you see Dave, no, he wasn't pre-funded with any tokens. So he's not able to pay this fee that we were looking at. He is requesting access to these computational resources without providing any form of payment. And so it's rejected. And I didn't have to code anything really to make that happen. That was all provided for me by the node template. So I feel like I've probably already gone far over time. I apologize for that. I hope I did a pretty good job of making good on the promise that you made for me, Stefan. Voluntold is the term that we use. I hope I did a decent job of making good on that, and I appreciate the opportunity to do so.
Dan, thank you so much. Really great. And I mean, not everybody is familiar with Rust, right? And every time you see all these phrases, the brackets, the double colon, lots of keywords, you don't even know what is the keyword, what's the type. But if it gets explained to you, it gets much more clear. And this is what I personally took away from that one.
Awesome. Yeah, Rust it's an interesting programming language. We work with the maintainers of the Rust language at Parity to help make it less scary for normal everyday programmers like you and I, and it does get better, I promise you. And we have a great technical chat that, you know, I love talking, and so anytime you want to come and you know, help me, I can help you go through your Rust error and, you know, kind of parse it out. Join our technical chat. You know, I dropped some helpful links in the workshop about other ways to engage with us and other kind of next steps. So don't be scared of Rust error messages. Just come chat with me.
I think they're quite verbose, so it should be helpful, but it's sometimes not that simple. The interesting part of Parity Substrate is, from my point of view, it already gives you like the boundary conditions. It already gives you the place where you write code into. So you don't have to learn everything Rust. You only have to understand the concepts if you're more interested into the blockchain thing.
Don't wait to learn Rust to learn Substrate. Learn Substrate and we'll help you learn Rust.
Exactly. Is there anybody from our still existent audience who wants to say something? If so, just raise your hand and we will invite you to the stage. In the meanwhile, I could ask a question of myself. Because we're doing quite a bit of Solidity coding lately, I know that there is an EVM palette, and I know that there is this Moonbeam project going on. So, I mean, there are lots of people onboarded on Ethereum over the last maybe 5 years, and Solidity compared to this kind of code is, of course, much simpler if you just write smart contracts in it. So do you know about, I mean, the state of these projects, and will they be usable? Will they be first-class citizens in the whole Substrate Polkadot ecosystem?
Yes, absolutely. This is a topic that's very, very near and dear to my heart. We are big fans of the Ethereum ecosystem at Parity. We really, really are. We come from the Ethereum community, and so it's a very important to us. And Ethereum has done a wonderful job of bringing a lot of this stuff that a couple of years ago sounded like a dream. They really were some of the ones that made it reality first. And when I say they, we are part of them. We're all one family in my mind. But Ethereum is a relatively specific use case. So one of the things that I mentioned about Substrate is it's very, very flexible, and flexibility brings complexity, of course. But let's talk about the Ethereum use case, which is a smart contract platform. So why would you want to expose a smart contract platform? A smart contract platform is a way to allow anyone in a permissionless way to deploy Turing-complete logic to your blockchain platform. That's kind of scary. Permissionlessly give them access to a Turing-complete machine. Oh my God, that's scary. Yes, and so you have to provide a lot of constraints around that. I was talking about the economic security mechanisms, the weight on that function. So Solidity and Ethereum does a wonderful job of encapsulating that use case, of allowing anyone to deploy Turing-complete logic to a permissionless, decentralized blockchain network. That might not always be what you want to do. In my case, I had a pretty straightforward idea. As pointless as it may have seemed, I didn't need anyone to deploy their own custom logic to my blockchain in order to allow people to register nicknames. That's its own thing. It lives in the runtime, and because it doesn't need to concern itself with permissionless, unidentified entities deploying Turing-complete logic to a shared computing platform, it can be much, much more performant and scalable and flexible. And so if you want to make use of a decentralized computing platform, and you think that the capabilities that Ethereum offers today in terms of scalability and whatnot and governance and everything are right for you, hey, Ethereum's a great network. I don't have anything against Ethereum. If that ability to allow other people to deploy their own code onto your platform, if that's not an important part of what you're doing, but if scalability and governance, we didn't even talk about governance. Governance is huge in blockchain networks, and governance is where Polkadot in particular, but then of course by extension Substrate, it's where they really, really win. And so if these things become important to you, like maybe you don't care about deploying smart contracts, but maybe you want to create robust governance mechanisms to maintain this registry of decentralized nicknames. Ethereum's not what it's designed for, come to sub.
You would deploy one DAO contract that's managed by votes to manage the nickname management registry or something, right? So this is where you will end up in Ethereum.
And all of this, you have to pay the extra costs associated with this smart contract platform. So it's a bad use of the abstraction. You know, if you go back to software engineers, what do? We leverage abstractions. Use abstractions the way they're meant to be used. And so if your use case kind of fits this pretty specific abstraction, Ethereum's awesome, robust ecosystem, everything, go for it. If that's not how you want to abstract your use case, come to Substrate, and we provide maybe sometimes a little more complex, but much, much more flexible mechanisms for doing these things.
Mm-hmm. But then it's actually, this was one of the questions that popped up during the talk, was actually also mine. I mean, if you write your custom node with a custom functionality, you have to, I mean, of course, you need some consensus if you really want to decentralize that. I think the idea is that you plug this into the Polkadot consensus somehow, right?
That's correct. And that is in development. The framework for building parachains is called Cumulus, and that is in active development. Can't really say too much about it, but what I will say is that it's a public GitHub repo. Everything we do at Parity is open source. There's not a whole lot of secrets with what we do. So if you just go to the Parity GitHub organization and check out Cumulus, it's all there. And if you have any questions about it, you know where to find me in Riot Chat, and I'll be much more inclined to give you a little more details there.
Dan, it was really a pleasure listening to you. And I think, so my personal clouds are cleared a little bit more. I don't know what's up with you people, if you also got a good idea now. If not, I also put that call to action link down there. You'll also find Dan on Twitter. Coding Earth's account just tweeted about them. And of course, this talk will be available online. Give me 1 week, okay? So let's see when I find the time to do the whole recording. Thank you so much, Dan. It was a real pleasure. And now you have a work day in front of you, I guess, right?
We'll see what happens. What day is it even?
Cool. So it was a pleasure.
Thank you, guys.
I'll just miss you here. Thank you. Ciao. You're
right.
Nice.
Still here.
We're still here. People. So people, as you might have noticed, today we only had scheduled 2 talks, which is good because Dan notably needed some more time. I also had just a check on our lightning talk Excel sheet, which nobody put something into, and I don't want to bore you with the ceramic setup we did. We heard lots of decentralized topics this time. Joao, if you could wish for something, what would you like to hear the next time?
Well, I think the memory leak talk was really cool, and it's my beloved JavaScript. So I would vote in another JavaScript talk, maybe Vue. We never heard a talk about Vue, so maybe that. And in the poll, you made a poll. So what type of JavaScript do people like? Native JavaScript or some typed thing? Yeah, most of the people like plain JavaScript. So maybe we could have some TypeScript talk to make people enjoy more TypeScript, because it's difficult to get into, but there's a lot of advantages of using TypeScript, right? So maybe something in that regard.
I can relate. So I would actually consider doing an assembly script talk compiling to WASM, running the WASM code on a blockchain. I don't know. So forget about all the blockchain stuff. Blockchain's over now. This was a great talk, and I would definitely recommend everybody doing it, but promise next time there will be a JavaScript talk again.
All right.
Blockchain's never over. Exactly. I must really say, I really appreciate it, because I'm also the decentralized guy in our company. I really love that. I only have to say, always have to, I mean, if you call yourself Coding Earth and Coding Portugal, you have to try to keep everybody together. So when I could wish for something, I would maybe vote up for FaunaDB, CockroachDB, or some database technology. Not because I'm personally really interested in that, but this is something that's quite hyped stuff currently, and that many people are maybe jumping onto from the old Postgres times. This is something that I would look for. Maybe some Rust talk. You never know. Cool. Okay. GraphDB is new. Yeah, if you want. So just suggest anything, you know, our Twitter handle. We even got a website with a contact box at the bottom, so you can just drop us a mail. And if you're interested into our little website, right? So this website is built with Gatsby on a Jamstack using GraphCMS in the backend. Everything is ultra fast deployed on Netlify, decentralized. I can also recommend Flixio, but this is another story. If you want to dig into website development like headless CMS website development, Jamstack development, hit us up. Improve our websites. You can even start with the cheap parts like improving some weird bugs we have on mobile. If you like Star Components, everything's written in React. We are here and have open ears. We're happily hear your suggestions what we can put on. Yes. So.
All right.
Again, the next meetup. The next meetup is going to happen, I guess, in August. Not August the 6th. There's a wedding of one of my very good old friends, Mr. Frank. He got married at the age of 42 in Bravo. But he'll do. But maybe the week after or something. So it's going to happen, I don't know, maybe August 20th, around that date, I'd say.
So submit us your thoughts so that we can schedule a date.
Weird, like weird database talks, Vue.js talks, TypeScript talks, whatever.
Cool stuff.
A slightly part of decentralized technology as well. Maybe I can contribute something. Okay, people. That was it from our side, right?
Yes.
Okay. YouTube will be closed down. You can watch the recap right after we close that stuff. If you want to watch it again and again and again, hit the call to action button, drop us a line on our website or wherever you want to. If you need an invite to our Slack channel, you can also just ask us. Maybe we are sharing it anyway. And yes, see you again then in later summer this year. Thank you very much, Coding Earth. It was a pleasure. Have a good one.